Welcome students. Today we are here to discuss about an experiment, the conversion of galvanometer into voltmeter. The range of voltmeter to be constructed is 3 volt. A galvanometer cannot be used as voltmeter directly because its resistance is not very high. A voltmeter must have very high resistance. A galvanometer can be converted into voltmeter by connecting a very high resistance in series with it. This is the principle behind this experiment. In order to perform the experiment, the apparatus required are the variable battery, the galvanometer, the variable resistance box, capital R, the voltmeter. So this is the variable battery. It has two terminals, positive and negative. Above it there is a knob which could be varied. This is the galvanometer. The resistance of this galvanometer should be known, that is Rg is equal to 56 ohm. The figure of the merit of this galvanometer also should be known, that is K is equal to 20 into 10 raised to minus 6 ampere per division. So the galvanometer scale has 0 at the center of the scale. The number of divisions on either side of 0 of this galvanometer scale is 30 divisions. So the number of divisions on either side of 0 of galvanometer scale is taken to be 30 division. So this is the variable resistance box. It has two terminals. So this knob where you could adjust the resistance from 1 ohm to 10 ohm. This knob is used to vary the resistance between 10 ohm to 100 ohm, and this knob from 100 to 1000, and this knob from 1000 to 10,000, and this knob from 10,000 and above. So this is the variable resistance box. Before we connect the circuit diagram, we should find the theoretical calculated value of series resistance, which is given by a formula R is equal to V by Ig minus Rg, where V is the range of voltmeter to be constructed, that is 3 volt. Rg is the resistance of the galvanometer, and Ig is the current in the galvanometer to have full scale deflection. Now you get the value for Ig in the formula, that is Ig is equal to Nk. So Ig is equal to N is nothing but 30 into K is nothing but 20 into 10 raised to minus 6. So you get 600 into 10 raised to minus 6 ampere. So the current in the galvanometer to have full scale deflection is nothing but 600 into 10 raised to minus 6 ampere. So we substitute in the formula R is equal to 3 divided by 600 into 10 raised to minus 6 minus 56, and we get R is equal to 4944 ohm. This is the theoretical calculated value of series resistance. Now our task is to find the experimental observed value of series resistance, which I have taken as R dash. So this value I will get it after connecting the circuit. The circuit connection is as follows. From the positive terminal of the battery, a wire is connected to one terminal of the galvanometer. From the same terminal of the galvanometer, one more wire is connected to positive end of the voltmeter. The negative end of the voltmeter is been connected to one end of the or one terminal of the resistance box. From the same end of the resistance box, a wire is connected to the negative terminal of the battery. From the another terminal of the galvanometer is connected to the left terminal of the resistance box. The switch of the voltmeter is been switched towards DC mode. Before on the circuit, a suitable I resistance is unplugged in the resistance box to safeguard the galvanometer. So I am going to plug 4944 ohm resistance. Now it is 4000, here it is 900. (44) ohm resistance I have plugged in the resistance box to safeguard the galvanometer. Now on the power, as soon as you on the power, adjust the variable battery so that you get an voltage of 3 volt in the voltmeter connected. Now a resistance in the resistance box is adjusted till the galvanometer shows full scale deflection. Now it is not showing full scale deflection. Full scale deflection means the pointer has to meet the last line of the scale. So I have to adjust the resistance box in such a way that the pointer meets the last line of the circular scale of the galvanometer. Now the pointer of the galvanometer is meeting the last line of the circular scale, means it is showing full scale deflection. So you can see in the galvanometer. Now note down the resistance in the resistance box, which is labeled as R dash. That is the experimental observed value of series resistance. Now it is 4800 10 plus 2, it is like 812. So 4812 is the experimental observed value of series resistance, which I labeled as R dash. So R and R dash are compared. So we have found the experimental observed values of series resistance R dash to be 4812 ohm, which is compared with the theoretical value. It might not be exactly equal, sometimes it might be exactly equal, sometimes it will be nearer to that value. Thank you.